Welcome, everybody. Today we're working on Unit 3. We're going to start with the lecture materials. We're going to go through a bunch of different topics, and then we'll take a break and get into some coding. Last week when we were working, we went through the process of making sure all our tools were working correctly, and I think everybody's okay in that regard. Also that we were able to connect our MySQL workbench to the server successfully, and then import a database and load the content by virtue of importing a SQL file that builds the database and all of its data automatically. And then we were able to run some basic queries, extracting information from tables. Now, generally speaking, when you start out, you usually focus on one table, just trying to get information out of it, and that was our approach. This week, we're going to ramp it up to try to get information out of 2 tables or more. And I think we're going to stick with probably the 2-table level, and there's maybe 1 3-table level little thing to do. But there's a whole bunch of concepts that go with it. Some of these are somewhat theoretical and kind of heavy to think about, so I'm just telling you that in advance. As far as the coding goes, we're probably going to stick with the inner join level for now, and then as you get more advanced in your database skills, you'll do left joins, right joins, and unions, and all that kind of stuff. But I am going to look at the concepts of joining tables. This really does boil down to this concept of how databases are relational. So instead of having one table of information in a database, most databases, the reason they exist is to break complex information into multiple tables so that we don't have redundancy of information inefficiently stored that we don't need. And then we connect the tables together in a fashion where the information from one table can augment the information from another table and work as one collective data set or database. All right, so let's dig into the first topic here, because I kind of played with this a little bit last week, by the way, without officially introducing it. And I think I back-channeled and added a little link about aliases on Unit 2 as a result. Now, before I click through this, the first thing that I'm going to say is that some of these links here, I'm going to pull them over to my Brave browser to start talking about them, just to strike the ads again. But aliasing as a concept is using a name other than the real name to represent something inside of a database. And we do this for a lot of different reasons. The one reason is the way stuff is named in the database might work for the database, but it doesn't work for us as human beings being able to read the code, right? Like first name or first underscore name isn't as friendly as just saying first space name, right? It's a little clearer. And we're going to look at aliasing now, not just for column names, but also for table names, right? And the idea is, instead of saying customer orders dot products or something like that, we would just use a single letter to represent a table name, and therefore cut down on the amount of coding that we need to do. None of the aliasing is, I would say, formally required, but a lot of database people do it so that the output of their query is prettier, and so that their code writing is faster, is really kind of the 2 reasons why we use it. Right, so I'm going to grab this link here, and then I'm going to jump over to Brave, and I know I already have it open somewhere, so there it is. And I'm going to go to that first link here on aliases. All right, so let's just kind of read through what they have here. And my hopes for you guys is when I publish a unit that you do some of this on your own. And for some of you, you will be able to like wrap your heads around it because of whatever your experience level is. And for other people, it might be like, oh my God, I don't get this at all. That's why I'm doing the lecture part of it, right, to explain it. Also, even if you do kind of get it, you might miss certain key aspects. So that's why I like to reinforce. All right, so it says aliases are used to give a table or a column in a table a temporary name, often used to make column names more readable. An alias only exists for the duration of that query. So we're not making a permanent change to the database by using an alias in a query. That's a really important concept, right? You could kind of equate that to the fact, like if I took a file on my computer and I save it to the hard drive, I can turn the computer off and bring it back. However, if I'm running something in memory and then I turn the computer off, whatever's in memory goes away, right? Like if I didn't save that document that was like sitting in memory, it's not coming back. And that's a really good example. An alias is created with the as keyword. Okay, I'm going to make an addendum here when you're doing a column name, right? When we do it on tables, there's a different syntax. So let's look at the basic syntax here. So you're just going to write a select statement, then you use the keyword as, and then you declare the name, right? So sometimes database people who write code like this will take a column name that is like first underscore name and say as F underscore name for whatever reason, right? And it really kind of look kind of the same. But other times you can put double quotes around it and then start dropping spaces into it, throw capital letters in, and make it look pretty, right? Usually that's going to be because you're outputting it for a user that doesn't get database concepts, right? Like, why does first name have an underscore in it? I don't get it. Like a normal user, right? Database people get it, normal users don't. So they have an example here, of course, the customers table that they use for a lot of these examples, and a selection from the orders table, right? Notice two different tables. So let's take a look at the example here and look at the code. So I'm just going to pull this up here in the Triad editor. I know last week we tried running this and it was crashing, right? You guys remember that? So we'll see what happens. But notice the select statement. It says, and I'll zoom in just a tad here so you can see it. So we're selecting the column called customer ID, and then we're going to alias it. So when we output it, the column header is going to say ID. Then we're going to take the customer name and we're going to alias it as customer. You see how both of those are more friendly, right? What's the ID? What's the customer? Yeah, it's a lot cleaner. All that information is coming from the customers table. Let's run the query, and it did work, and see what the output is. Now, conversely, right? What we could do is we could remove these aliases, and you can see the comparison of it without. Is it not a little bit more friendly with the aliases? Well, you could argue that. A database person wouldn't care. A normal human who's not a database person would go, I like the other way better. And truly, it makes more sense when you think about it, right? It does. Right. So that's a basic alias. And you can actually take it further, and let me just kind of see if I can Control Z here. Fantastic. You can also put quotes around it and do something like this. And truly that it's a full name, so you might even label it more clearly. And then the output turns into something that's a lot more readable and understandable. This is why we do an alias, right? I don't know what the purpose of the query is. So this is the other issue that database people have. Like, why are we running this query? For our own sake to do something internal on the database? Or am I running this query to show it to like my manager who needs to make a decision on the information? Right? And in those scenarios, the way you label stuff makes a big difference. Let's go back. Now let's check out the, okay, so I don't want to scroll past this too quickly. So they did the string approach here, right? They also can combine it. So you can do like concatenation in there if you wish, right? So you can concatenate various fields. So I could take like the customer name, just pull that in as is, and then concatenate that with a comma and a space, the address, the postal code, the city, country, and list it all as an address in one column. That's doable too. I'd say that's kind of advanced, but not so much. It depends on how you want your output to look, right? Instead of putting all that stuff in separate columns, it's not actually that weird to kind of come up with output that looks like this. So here's like just the whole address with stuff that resides in different columns stuck together into one. And then if maybe you were putting into the, like, I don't know, into UPS software or something, or printing it to a shipping label, this format might be better. Maybe not. That's not maybe a great example, but you can see kind of the fact that you can conglomerate columns together, all of their content, and give it a separate name. And I think that's really kind of a neat feature. All right. Now, we also have aliases available for tables. This is kind of a weirder thing because I think I demonstrated this last week. Like when we are working inside of a database, what's one of the first statements you type, you guys? You type the use statement, right? And the use statement is, well, if I have 5 databases loaded in MySQL Workbench, how do I know what query this is attaching to? Well, if I run the use statement first, then I've attached to the database, and then all the subsequent queries we know. But, as we kind of move forward, we also learn the fact that we don't have to use a use statement if I declare the database name dot the table name, right? You can use that syntax and it still works, but it's a lot more code to write. That's why we use the use statement. Now, when we start to combine multiple tables together, we also run into this issue. Well, sometimes table names are short. Customers and orders aren't really very long names. But what if it was like customer order detail or something like that? That's kind of cumbersome to type every time. So what a lot of SQL programmers do is they take the table names and they just say, okay, well, I'm just dealing with customers and orders. I'll alias customers as the letter C, and I'll alias orders as the letter O, right? And you see how that's on the from line. And this is where I feel SQL is kind of backwards sometimes, because you declare the alias on the second line before, kind of basically after you're already using it on the first line. So sometimes when I write queries like this, like I know which columns I want to grab, but I do this part first so I remember what the aliasing is. And that's how my brain works. So I'll point that out as we're coding later. But the customer tables now will just be referred to as the letter C, right? So this says customers table and the column is customer name. This allows us then to actually call 2 different tables in the query. So here I'm calling the orders table, which is aliased as O, and that particular column, another thing from the orders table, and then another thing from the customer table. And basically what I'm doing is I'm joining information from 2 tables into one query. There's different ways to do this. And the approach that we're seeing on the screen right here is what I call kind of like the raw cross-table query without using joins, which is our next topic, right? Notice also in the output, right? In the where clause, right? Not only are we aliasing it, but we're looking for a specific customer name, right? And apparently there's a business called Around the Horn that's a customer. And then we're also doing this criteria, and this gets a little bit more advanced, but like how are we connecting? Think about this. If I'm grabbing information from one table, then grabbing information from another table, how do I know that I'm grabbing the right information related to that customer from the order table? Well, here's how. I make sure that whatever stuff I'm pulling back in the customers table, customer ID, with the equal sign matches the customer ID in the orders table. It doesn't make sense otherwise, does it? Right? It does not. So this is one of the joining mechanisms, and this is before we're talking about joins. But if you want to see what this looks like, you can run that query, of course, and see the output, right? So the customer name, this is coming from the customers table. These 2 fields are coming from the orders table, but we're only pulling stuff back where the customer IDs match. Notice we're not displaying the customer IDs. We could display those too if we wanted, but in this case, it wouldn't even appear on the screen unless I have a customer with an ID in the customers table that also has an order in the orders table. And more specifically, I mean, this is a compound where clause here because we have an and statement in the middle, and we'll talk about and or and not in a bit. But because we are looking for one particular customer, so we only want to see the orders from this one company is really what this query says. For this company, customer, whatever, I want to see only orders from that company. It's not exactly how you would think it would be done if you were doing it intuitively, but in SQL code, we have to get really granular in terms of like what we're pulling up. It is nuanced. If I remove this piece, right, we're matching the customer name. So we're just looking for IDs that match. What's your predicted output? Here's the question. Because right now we're seeing just one customer. All right, let's run it and see. Well, it pulls back everybody who's got an order. That might not be what you want. You see the difference? So these are all the customers that are in our customers table that actually have placed orders. Right. So that's our alias. So a lot of concepts wrapped up in there. Let's move now to joins. Joins are really important because basically, look at the definition here. A join clause is used to combine rows from two or more tables based on a related column between them. Okay, so the concept is where I did my where clause in the previous screen, and I was trying to link together the customer IDs, and I did it in what I would call brute force fashion, right? The join clause does this with a different mechanism, and you declare it a different way. So first they're letting you look at the orders table. So the orders table has an order ID, customer ID, and order date, right? And I want you to notice that that's all the information in that table. It doesn't tell you what was ordered, if it was shipped, how much it cost. So this must link somewhere else. And then the customer ID links back to the customer table. So you see like kind of the magic sauce here. Somewhere else we have an order details table that holds the order information. Somewhere else we have a customers table that holds the customer information. I don't need to repeat all of that information here. I just want to know which customer made this order and on what date. That's what this table does. Okay. So this table is kind of simplistic. Here's the customers table, right? And I don't think they're showing us the orders table, but that's okay. So let's go now, and in fact, I want to read that little snippet there. And maybe I should do this too. It says, notice the customer ID in the customer orders table refers to customer ID in the customers table, and the relationship between the two tables is the customer ID, right? So what they're saying is this customer ID column, this one here, connects to this customer ID column in the customers table. So when this says customer ID number 2, we're talking about this company, or customer name. Okay, so then we can create the following SQL statement that contains an inner join that selects the records that have matching values in both tables. So I'm going to go ahead and go to the thing here, and I think I already launched it, so maybe that's why it failed last time. Who knows? Let's look at the syntax. Here they're not using aliasing. So if you want to practice your aliasing, you could do it here. I could say orders as O, right? And then everywhere up here where it says orders, I can just drop in the letter O. Right? I won't do it with customers, but you get the idea there and why that's easier. All right, so we use kind of the same syntax. And then we get right under the from statement, we say inner join customer. So notice that the core part of the query isn't indicating two tables here. It doesn't say from this table and from this table. It just says our primary table we're pulling from is the orders table. We're also interjoining that with the customers table. And then we indicate which field we're joining on. So we have the on keyword here as well. So we're indicating orders.customer ID. And notice I'm changing the aliasing here. And I could add aliasing here as well. So I can make that a C, and then all the customers could become a C. We'll run it. You can see the output here, and you see that it worked. So it selects columns from multiple tables. We're joined on the customer ID. But you see how the syntax is very similar? So if I do a raw brute force joining of two tables, it's basically an inner join is kind of the secret sauce here. So when we do our first exercise, I'll demonstrate that as well, just for repetition. So that's what we call standard inner join, and it shows you what the output are, or is, I should say. Now we're going to do just kind of a brief overview of what these joining methods mean. And I know that some of you will look at these graphics and I'm throwing up on the screen here. It's like, oh man, this is like math class, ew, and I get it, right? Did you guys ever do that kind of thing? And usually you do this like in a statistics class, or you have a unit on statistics and they talk about union and intersection and all that stuff. Does that sound vaguely familiar? You guys ever do that? Okay, maybe not. But an inner join, basically what we're doing symbolically is we have one table of information, and then we have a separate table of information. And what we're really looking for is the intersection of information. So the information that's in both tables, that's what we're looking for when we do an inner join. I don't want, like the one example I did where I took away, the narrowing down to that one company. Do you notice how the inner join, I didn't have to write like the company? I could indicate it a different way. But an inner join grabs the intersecting information. There are different types of joins as well, because there are situations and they tend, there's logic that drives it, like business reasons or information reasons, that you can do a left join. So you include everything from one table and only the part from the second table that you need, or you can do the converse. And it's a matter of like how you list the order, like which one is in the from statement and which one is in the join statement. It's the order of which you do it. So far, we're going to just focus on inner joins mostly in this class because the left joins and right joins get kind of theoretical. We also can get into what we call a cross join. That's also called a union, by the way. But I just want to make you aware of all those different modalities. If you want to really dig in here, right, like you can get into the inner join and read up on it. We just did one of these, right? The left join gets a little bit weirder and they reinforce that whole thing, but we're still joining the table. But the difference is instead of getting that intersecting piece, we get all of what's in table one as well. And then the right join does the same thing on the other side. And we're pulling it from the second table instead of the first table. And then the cross join, which includes all the information from both tables, which is a little weird. The left, the right, and the cross join are specialty situations driven by the logic of what kind of information you're trying to extract, basically. I'll leave those topics there. I think that's kind of enough to wrap your head around for right now. Then we're going to start looking at the operators in the where clause. And I do this because I kind of, once again, already introduced them sort of informally, but I want you guys to get this understanding of what this really means. So when we write a where clause, and we did an example of this, right? We were looking for one customer and we were looking for their IDs to match, like order IDs to match. The where clause, it really sets the criteria. It's kind of like a filter for whatever query you're writing to narrow down the results. So you have a condition that you're checking for, and often it's maybe, I just want the customers from Mexico. All right. Sometimes your queries are that simple. But you can also, make it numeric. I think we talked about that last time. But you can also use these operators in this table, which I think are pretty critical. So like if we're doing math, right? So if I'm looking for a specific customer ID and I want the stuff to be equal, right? So customer ID equals 1. It's only going to pull back that one, right? Because it's equivalent. If I'm looking for an order total that's greater than $200, I would use the greater than symbol. If less than, etc. And then notice how they do greater than or equal to, right? So if you guys are new to coding, like in regular math, you do the greater than and you put an underline under it. That's not how you do it in coding. In coding, you have to like physically include the equal sign. One that's really kind of weird is this one, the not equal to. And the only other programming language that I've seen that uses that syntax, which is the greater than or less than and greater than together, is Visual Basic, which is kind of fading away now. But I also want you to be very aware of this. And I tend to use this approach that I just highlighted because that's how you do it in most languages, by the way, is you say exclamation equals, the exclamation is a negation symbol. It's instead of equals, it's not equal. I tend to like that better, but really the formal way to do it is here. I want you to notice that they have some other ones here, that one of which we've already used. So you can actually set a range using the keyword between. You can also use the like keyword, which actually searches for a string of text in a given pattern. Like usually, like we'll throw a string of text in there. We usually want it to be exact, and we use the like keyword, or we use the equal sign. Or you can give it a list of possible values. So I want the people who are, I don't know, this age, and this age, and I can give it 3 values, and it'll say we use the keyword in. All of these have examples if you want to check them out. I'll use the ones that we need for coding, but you can always dig in here and explore this stuff, and I would encourage you to do that, right? You got the time to plow through those materials. All right. I know another topic that we have here, and I was hoping to kind of hit them in order. Let me hit like first, right? Because we've been kind of using this one already. And basically, this is used almost exclusively in where clauses, basically to search for a certain pattern in a count. There's 2 different ways to do wildcards. Wildcards are kind of like it represents anything. You can use the percent sign, right? And I want you to notice the little thing that follows it. The percent sign represents 0, 1, or multiple characters. Kind of weird, right? You can also use the underscore, which represents 1 single character. So I'll give you an example. If my name was, I don't know, like maybe we were searching a field that had a customer name, and it was like John Mark Smith or something like that. It's like the full name. And I'm just looking for anybody who's got John in their name, right? I would use John %, and then anything else that follows is fine, right? Doesn't matter what else follows. If I use the underscore, I'm just looking for one particular thing that can be different. All the rest of it has to be exact. I don't know if that makes sense. The examples would probably be a little bit different. Generally speaking, a like command is like we did the Mexico thing for a customer. You just put the word Mexico in there. As long as it's in the database correctly, it'll be fine, right? It'll come back correctly. What if somebody misspells the word Mexico, though? Putting the data into the database. There's a challenge. Yeah, it's wrong. But chances are, and here's like the kind of stuff you think about as a database person, they probably type MEX correctly, but maybe they superimpose the I and the O, or mistype, the rest of it. So you could do like MEX %, and that would catch the rest of the word, even if it was misspelled. Now, also a clever database programmer wouldn't let bad data go in. they would write code to prevent that from happening, but that's a whole more advanced issue. You can also take a bunch of different values and combine them with and or, and we'll talk about what those mean soon. But they give you an example here of all the different types of scenarios and the syntax for like statements. And once again, I would implore you to kind of explore those on your own. I think it's a little bit more readable if you zoom out a little bit, how to use the wildcards. Right? So check that out, read through that. They have some examples of this. This can get pretty advanced. Right now, generally for us, we're going to be looking for specific words, right? And we'll just put quotes around it. We'll say like Mexico and then move on. And that'll be our approach. You can get very granular with this stuff, especially when you're dealing with not clean data is a polite way to say it. All right, let's go now to and, or, and not. And I'm going to say that and, or, and not are very, very important, not just for SQL, right? So if you guys are also in the Python class right now, some of you are, or if you're doing any other programming language, basically we have these three keywords to do logical combinations or non-combinations of things, maybe is a good way to say it. And you usually use and, or, and not in SQL statements inside the where clause again, because we're setting criteria or a filter. And it says and or operators are used to filter records based on more than one condition. The and operator displays a record if all the conditions separated by and are true. So if the order was placed within the last month and the order came from Mexico, show me those, but both have to be true. The other operator, or, displays the record if any of the conditions are separated by or are true. So not all of them have to be true. See the difference? So I would always do these like goofy examples on and or not that I do in my Python class. Like, you know, if I have $20 or more, I can order pizza for dinner, right? What if I don't? I don't have pizza. Maybe that's not a good example. The not operator displays the record if the condition is not true. So there's situations for all of these. And what I think is helpful, right? So they show you all the syntax here. So and, or, and not. The top one's the and in this case. And you can set multiple conditions with ands and ors. Now think about this. In an and condition, every one of the, whatever we put here, like, you know, order equals 200, country equals Mexico, customer name equals Joe's Guitar Shop, something like that. Every one of the conditions has to be true in order to stick. If one of them is false, it will not pull it back. It won't pull that into the result. With the or, only one of these has to be true, and we get a result. With the not, it would be the opposite of the condition being true. So I might say, you know, give me all the orders from this customer, not in Mexico, you know, or that type of thing. And you'll get everything that doesn't come from Mexico. I have a couple of examples here, right? I'll just run these really quick so you can see them, right? So we want the customers that come from the country of Germany, but not just all the ones from Germany, but also from the city of Berlin. So we'll only get Germany and only get Berlin. And guess what? There's only one word. If we do an or example, right? We're either looking for Berlin or Stuttgart. Now think about the or condition here. Well, it can't be in both places, can you? Well, maybe the customer's got multiple locations, but in theory, right? Let's say this is a person. You're either living in one place or another. So we only want customers from either Berlin or Stuttgart. So what's the result of that one? Well, we get one of each. Give you an example. It's Milwaukee. How many of you get that? There's no Milwaukees in the table. I happen to know that, but Berlin was true. I don't need Milwaukee to be true to get a result. Just one of them has to be true. That's how ORs work. And then finally, there's a little example here for not. So we want all the customers that are not from Germany. So what's going to be the result? Every other country in the database. It's the converse. That's our and, or, and not little thing. And that covers all our lecture topics. I do want to point out that there's this reference video, if you guys want to check it out, where it goes a little bit deeper into left joins and right joins. And like I said, for what we're doing here in class, we're going to focus in on the inner joins. All right. I am going to pause. Actually, I'm not sure if I'm going to pause the video or stop it. I guess I'm going to stop the video here. So this video is basically over and we're going into a break, folks. So this video is done.